morning, AP. We're going to talk about 2.5, the periodic table. We all learned the organization of periodic table last year when we had CP and honors. Mr. Mendeleev organized the periodic table first by two ways. So originally, the periodic table was organized by two ways. One, mass, increasing mass, so lowest to highest mass, and chemical and physical properties. Okay, so what he did was he grouped them. He grouped elements that were very similar with each other. Don't use the word same because they're not the same. So anyone that was very chemically, chemical properties that were similar to each other, he grouped them. So on our periodic table, so elements in the same group, as in group, as in going down, they're very similar to each other. Okay, so all these elements right here, and then these elements, they're all grouped. So groups going down, and there's 18 groups on the periodic table. So every element in that same group are very similar to each other. So that's how he organized it. We know that is not how it is today. This one got changed, and we do it now by atomic number. And Mr. Mosley called it atomic number based on his research of using X-rays. It's also the number of protons. So the smallest proton being hydrogen all the way to number 118 over here to the highest amount of protons. Okay, so we do it by the atomic number, but it is really the protons. Because remember, what's important about the protons is it identifies the element. Okay, it's the atom's identity. So in a periodic table, you have two grouping systems. You have periods, and periods go across. There are 7, so as you go across the periodic table. And then you have groups. There's 18 groups. So from group number 1 all the way to group number 18. But you also have a different grouping system, the A's and the B's. So I'm going to put my periodic table up so we can write on it. Let's see, where's my periodic table? There it is. Okay. So right here, as you see on top of these groups, you have a different numbering system. You have these A groups. So the A groups, alright, sorry I had to change my pen there. There you go. So the A groups are called the representative groups. And the B groups, as you see right here, those are the transitions. So if you notice on the periodic table, if you count them, you have an A group here, 1 and 2. If you jump all the way over here to boron to the end, those are your A groups. So you have 8 A groups. Now that's going to mean a lot when we talk about valence electrons, because those are the most reactive elements, is those A groups. They also sometimes have the name main groups. Either one is fine. I usually call them representative. The B groups all the way in here. So all of these elements in here, those are your B groups. And same thing down here. These are also part of the B's because all of these 14 elements here and 14 elements down here, they fit right here in the periodic table. So you have 10 different groups for the transition. Now I don't want you to think that you actually have more than 10, because these ones down here, if you notice, they don't have any group numbers on them because they're not really part of a group. They're part of a period, but they're not really part of any particular group. So they just fit right there in the periodic table. Also in 2.5, the different type of groups. So right here, as you see the color coding right here, you have group number 1. So I'm just going to label it right here. Group number 1A, you have the alkali metals. But be very careful with group number 1. Notice hydrogen is not shaded in that red color. It's because, one, hydrogen is not even a metal. So you can't call them an alkali metal. So everybody in group A, but I'm going to make a note, not hydrogen. Group 2, from beryllium all the way down to radium, those are the alkaline earth metals, so 2A. All of the yellow right here in the middle, those are your transitions. So we're going to say 3B all the way to 2B. Now notice over here, before you're thinking 3B to 10B, the numbering system is a little bit wacky over here, and it's no purpose why you need to know why it does that. But it does go all the way from 3B to 2B. I like to think of it as group 3. Oops, I can't even write right there. Let me write it right here. Group 3 all the way to group 12. So if you count right here, you got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from actual group 3 all the way to 12. So you can number it like that too. Over here, the very last group, so we started over here, so now we're going to start on the right side. So the very last group, this kind of purple-ish group over here, and I know the coloring's a little bit off here, but 8A, those are your noble gases. So the group 18 all the way at the end, those are your noble gases. And then this lighter purple group, so from fluorine all the way down, so 7A, those are your halogens. These are like your salt makers. So these elements, fluorine all the way down, they like to bond with the metals to form salts. You have some other basic coloring over here too. It's just they did the group part first. So basic metals, so your metals category, let me kind of do this in a highlighter. Your metals go all the way from here. These are all of your metals. Okay? And then you have like a staircase. Let me see if I can change the color. Okay? You have a staircase that goes like right here. So remember the point of that staircase. Okay? That staircase is to separate the metals from the nonmetals. So all of this blue region, let me go back to my blue. All of this, okay? Let me go right here. Right there. Those are all of your metals, okay? So as you see, 3/4 of the periodic table, those are your metals. So I'm going to label this metals, okay? So then you got another category called the nonmetals. So the nonmetals, I'll do mine in orange. Your nonmetals are over here on this side of the periodic table. So one side on the staircase is metals, the other side of the staircase is your nonmetals. So from about carbon all the way to helium, and we'll go right here. Okay, there you go. So those are your nonmetals. Okay, but don't forget one very important element over here, Mr. Hydrogen. He is also a nonmetal. Okay, and we'll explain why he's in that first group when we get closer to valence electrons. And then you got your last group, the metalloids. Okay, so from boron, so basically anyone that touches this staircase, they are a metalloid. So I'll just circle the symbol, Mr. Boron, silicon, germanium. So as I said, everybody that touches that staircase. Okay, and I'm not going to do this one down here because I'm not too familiar with these new elements, number 17 and 117 and 118. I'll just leave those alone. So if you notice on here for metalloids, they have properties of both metals and nonmetals. Usually they physically look like a metal, but they react like a nonmetal. Now be very careful with Mr. Aluminum. Aluminum is not a metalloid. I know he touches the staircase, but he is absolutely 100% metal. Okay, so those are your different properties of the periodic table. So you have 3 groups of elements. So 3 groups of elements. Let me write those down. So 3 types of elements. Okay, you can either be a metal, a nonmetal, or a metalloid. Okay, and then you have various different groups that are on the periodic table. Okay. Lastly, when it comes to states of matters, okay, so states of matters, let's talk about the metal side first because that's very easy, okay, so maybe let's go maybe pink. Every metal is a solid except for one, Mr. Hydrogen, okay, so Mr. Hydrogen, he is a liquid, okay, so we'll put right here pink, maybe like a little key, liquid. Okay, because we're not going to label all the solids because most of the periodic tables are solid. So right there, Mr. Mercury is a liquid. And then there is one nonmetal that is a liquid also, and that is bromine. So I'm going to shade Mr. Bromine in there too. So on this periodic table, the whole periodic table, there's only 2 liquids. Okay. Now, the other category for states of matters is gases. So I'm going to do a little coloring in there too. Let's pick this little maroon. So with maroon, okay, make a color key, there are 11 gases. Now, the gases are non-metals. There are no metals that are gases. So these are 11 gases that are naturally found as a gas. Now we can make any element into a liquid or a gas, but these are naturally gases. So I'm going to color code their symbols. So basically the easiest ones first are the noble gases because their category pretty much says they're gases. So you got one there, helium, neon, argon, krypton, and xenon. So there's 6 right there, and radon. Okay. And then you got chlorine, naturally a gas. It's a yellowish, greenish gas. You got fluorine, a gas. Obviously oxygen, we're breathing it, and nitrogen in our atmosphere. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 gases. So who's number 11? Don't forget the guy in the corner, Mr. Hydrogen. Okay. So if it's not color-coded pink or this maroon, then they are all naturally solids. So if you notice a trend here, a very, very valuable trend to see, is anyone closest to the staircase on the non-metal side, so carbon, phosphorus, sulfur, selenium, iodine, all of these ones that are closest to the staircase, they're all solids. But where are the gases? Those are the elements further away from the staircase. So that's how you remember. I don't know why students tend to think carbon is a gas, but you got to remember carbon's a solid. 3 types of carbon out there called allotropes, the same element but a different form. Carbon as in coal, black solid. You got diamond, okay, diamond. Always remember diamond carbon. And then you got graphite, okay, what you're writing with a pencil. Okay, so they're all solids. Carbon is not a gas. Okay, so hopefully, ladies and gentlemen, you labeled your periodic table and you know the different parts. When we get to chapter 7, it's basically the whole organization of the periodic table, the history of the periodic table. So we'll come back to this, but this is a general dividing up the different parts of the periodic table.